That sounds like a. There we go. Okay. Thanks, Bill.
Wonderful. Good afternoon. And I hope you're having a fabulous day. I'm here representing Safer STEM on behalf of James, who couldn't be with you today. He'll be with you in person in March, I believe that is. He's coming down. And I am just going to share my screen here to show you what we're up to today. There we go. I hope you can see that. We are looking at lab safety in schools. And you can see by the agenda that we have a number of tasks that we'd like to go over. So given that we have an hour and a half and we have quite a few bases to cover, I'm going to get started right away. Questions? If you have questions, I had the chat up, but the shared screen has moved the chat out of the way. So is there a question?
We can figure that out. We can take them as we go, Phil.
Okay.
And we can get to you later. Yeah.
You bet. Okay, so let's get this in presentation mode. There we go. So the goals behind this, in terms of a classroom, we sort of go by these strategies. A safer tomorrow begins today. We believe that safety comes first so that accidents happen last, if at all. We believe that being a professional science educator comes with responsibilities that go beyond the lab. And we believe that everyone should go home safely at the end of every day. And we understand that safety regulations in Michigan are enforced by MyOSHA, and they're aligned to the federal OSHA standards, and they follow the same numbering system as OSHA does itself. So just a few case studies to let you know that things can happen. In 2017 in Fairfax County, Virginia, 5 students were working with the teacher using methanol, and you're going to hear me talk about methanol and how I believe it's the worst substance you can have besides mercury in your chemistry lab. They were doing an experiment with methanol, and because it is so flammable at such a low temperature that the minute it comes in contact with flames, quite often flame balls erupt or flame jets erupt and people get hurt. So in Virginia, 5 students were seriously injured and it went to court. Merrill Hyde Magnet School in Hendersonville. The schools were closed after, one second here. I have to minimize this. After 12 students were accidentally burned in a chemical flash fire in the science lab there in 2018. All of these made the news. That is not how you want your school to make the news. So we are here today to try and mitigate those possibilities. In San Diego, in 2019, a Mississippi student, his name was Priest Rivera. He was only 13 years old. His face was severely burned due to recklessness in the classroom, and that was exactly how he was found in court. He was found negligent and reckless in the classroom by performing another methanol experiment, and he is scarred for life. A large settlement happened there. And in October of 2022, at Dinwiddie High School in Virginia, a chemistry teacher with 15 years of experience and 4 students were burned when methanol igniting during an unsafe demonstration. No personal protective equipment or preventative measures were used by the teacher or students. The activity was not known to the school admin. No potential safety hazard analysis or resulting health and safety risk assessment had been done prior to this activity occurring. So in all of these cases, there were many things that could have been done to prevent this. Number one being don't work with methanol, but we'll get into all of that as we go. So in terms of accidents in classrooms, does anybody have any guess from grades K to 12, which single grade has the most accidents statistically? No guesses?
I got a 10 and 11. Most are saying 6, 10, 11. I got an 8 and a 9. Most are hitting that high school chem land a little bit.
Okay. All of which are fabulous guesses. Here we go. Grade 9, 70% of lab accidents and injuries. That means 30% are spread amongst the other 11 grades. 70% in grade 9. So have we got a couple ideas as to why this happens? And I can't hear the crowd, so you may have to relay it.
Yeah, we have horsing around. They're freshmen. What else? Lack of experience with labs coming into high school. Those are some of the top ones here.
And they're all correct. All of those are correct. Add in hormones and their fine motor skills still developing. Yeah, we have our first formal lab experience, and many of them from K to 8 were probably using plasticware, not glassware. So they aren't aware that they can drop and shatter. But the other side of this, that's the student side. There is a staff side to this. How many people voluntarily take grade 9 science as a teaching assignment? A lot of people get assigned to freshman science.
Yeah, there was a very large laugh in the room for that, Phil, because nobody wants those freshmen.
Exactly. Exactly. So we have new people, either new to the school, new to the subject area, or just new to the profession, also taking the reins in grade 9. So you there's a risk of almost blind leading the blind. If you don't want to be there and you're trying to do labs, things can go very badly. So how can we mitigate that? How can we mitigate the problems with grade 9? I have some ideas, but I'd like to hear from the crowd. Do we have any solutions to that?
Thoughts? We've got a training is in the chat. Any other thoughts you guys have out there? What do you think? Spend a significant amount of time talking about lab safety, for sure. Jason?
I was gonna say, like, switch up where the curriculum's at, like, probably shouldn't do like chemistry at 9th grade.
Oh, chem at 9th grade might not be a good idea. Okay. Model safe practices, Jason? Yeah, go ahead.
Well, and just more labs earlier on. Don't wait until high school to actually break out the scalpels and the stuff. Like, expect students from early grades to follow safety.
Yeah, sure. Some K-12 safety protocols, thinking about it throughout the system, not just within those high school courses. I find that crazy because like I had a chemical cabinet in 8th grade that was, we won't discuss what it was, but we'll keep going. Okay, we've had a lot of pretty good feedback back here, so yep.
Yeah, the mic is picking it up and I'm hearing them and they're great ideas. One of the things we talked about safety training with students, OSHA recommends that we do annual safety training with staff as well. So we got to make sure that we keep both sides of this fence occupied, that teachers should also never run a lab with students that they've never run themselves first. Never go to the students and say, well, let's see how this goes. That's not a line you want to use in a chem lab, ever. I also recommend that we use something like Flynn's student safety contract. Have you seen those? Flynn offers for free a student safety contract that you can use in your classroom and have students take it home, get signed by their parents. It covers a lot of ground that you would cover in your safety training. One other way, remember we talked about how grade 9 may not have been a chosen area for someone to teach. So one way of avoiding some of these problems would be to have a mentor program of one of those senior science teachers that's been around for a few years, that has a little bit of that background that they may not, then mentor them up and get them to run the lab together before they run it with the kids. Sound like a plan?
Yeah.
All right. So let's talk about our basic safety training. That's what we're here for today. And this is what we would typically run through as an annual review for safety training. So first thing that you can get at before the school year even starts is to make sure that clutter in the lab is gone. And unfortunately, we have lots of people that teach lots of different subjects, so they accumulate a lot of stuff. And they typically say that in your department, there is typically one person that could be labeled the pack rat. And if you don't know who that is in your department, it's probably you. So we need to take a good look in the mirror and say, hey, so if somebody's making a beeline for the fire extinguisher, is there stuff in their way? If they try and grab it, is there stuff blocking it? Can they get back to where they need to use it quickly and efficiently? So we like to try and keep that space as clean as possible. Likewise with your prep room. Try and keep, I know there are prep rooms that you inherit 50 years of accumulated mess, but somebody's got to clean it up somewhere, somehow. Maybe it's a department event, but we have to get her done somehow. So we would like to keep as much stuff associated with the lab and the prep room as neat and as tidy as possible, especially the demo bench. Fire safety. Everybody knows the importance of having a fire extinguisher in the room. Now, how often would you say that that fire extinguisher should be inspected to say that it's at the 100% ready level on the gauge?
Annually.
Annually. Annually. I know that one.
So the recommended practice is monthly. But
Really?
you-
Somebody said
monthly.
monthly.
But you don't have to bring the fire marshal in to do that. You can do that. All you got to do is make sure that that needle is still pointing in the green every month. But you do have an annual inspection by the fire marshal that includes checking out the fire extinguisher and punching the tag saying that it's been inspected. But you should do it monthly to make sure that the pressure doesn't drop in there and it loses functionality. You should have a fire blanket somewhere up in the room, again, with a clear path to the fire blanket. Buckets of sand. Well, that says plural. A bucket usually is sufficient. And of course, a first aid kit in the room with stuff in it. If you walk into a classroom for the first time and see a first aid kit and think on the wall and think that's great, open it and make sure there's something in it. The Band-Aids may have been used and gone. And of course, you should have signage up in the room indicating where all these safety features are in your room. A fire safety plan as recommended by NFPA's 101 life safety document recommends that we have those ABC dry powder type extinguishers mounted on the wall. They typically say they should be 40 inches off the floor, not sitting on the floor. And it's service tag, like I said, check monthly so that the gauge says it's 100% charged. That's that green zone on the gauge. You may have other local or state fire marshal regulations that you have to follow as well. That would be over and above what's in the NFPA's document. Your fire extinguisher, we've all seen these red fire extinguishers around. Hopefully everybody knows how to use them. Have you all heard of that PASS acronym for using a fire extinguisher?
I'm getting mixed, yes, some heading nod yes, some heading nods no.
So PASS does not stand for pray and shoot something. So PASS is just point it where it needs to go. Well, P is pull the pin first. You pull the pin, aim it. A is the aim. S is squeeze the trigger. And then the other S is sweep. You sweep that fire extinguisher. Statistics show that if you sweep it from left to right, you'll put out more fires than right to left. Well, if you believe that, there's a bridge in Brooklyn that I think you'd be really interested in. No, I'm kidding. Which direction you sweep has nothing to do with how effective it is. So, PASS, the little acronym, pull the pin, aim, squeeze, and shoot. Now, one thing you should know is when you use these extinguishers, the first little puff that comes out on the first squeeze is the most pressurized. So if you have a loose, flammable target, as I did in my second year of instruction. I had a little glass petri dish on an overhead. That shows you how old I am. And we were looking at sodium and showing that we can cut it with a knife. Just the humidity in the air got that sodium to burst into flame. Now, fortunately, it was a little chunk, so I grabbed the fire extinguisher. But when I pointed it at that little dish, that first pressure thing sent that about 20 yards downfield. Well, 20 feet downfield. And it shattered into 22 little bonfires on the tile. So we put them all out, but of course the room was full of powder. We had to take the students out. It was a mess, to say the least. So that first little puff, be aware that it can really mobilize whatever's not bolted down in its path. After that, the pressure stabilizes and you're good to go. Okay, how many people have used a fire blanket, or if they haven't used a fire, how many think that you should be wrapping a person up in a fire blanket to put out the fire?
I have a lot of nodding no's.
Okay, good plan. Don't do it, because if you wrap them up, what happens is the flame have only one place to go, either out the bottom or out the top. And what's in the way at the top? Your head. Yeah, exactly. Exactly. So you end up with very serious burns on your face and on your neck. So stop, drop, and roll sort of idea is an actual thing. Get them on the ground and smother it with a blanket. Do not cinch them around like a carpet roll, because they will get burned. All right. So here's some items that I think everybody should know how to use, not only the fire extinguisher, but a bucket of dry sand for coating the flames to cut off the oxygen flow so that it will not burn. Your fire blanket, whether it's in a metal case, whether it's in a round cylinder and you have to yank it out, whichever, and know where your closest fire alarm is in case we need to evac. So hopefully that's just common sense. Moving on to eyewear. How many people think the eyewear in the bottom left is sufficient for doing a chem lab with a Bunsen burner?
No, I'm getting a lot of no's.
Yeah. So those are good for dry labs, physics labs, projectiles, those kinds of things, as long as they have the side eye shields on them. But as soon as you have chemical, flames, liquids, you have to have these indirectly vented splash goggles, the Z87.1 D3 2020s. There will be a stamp somewhere just behind the faceplate indicating that those are in fact the regulated types of safety goggles to be using. Now, if an inspector happened to walk by and your student wasn't wearing one of those, do you know what the inspector's favorite number is when he sees that?
We got 911 and 10,000.
Okay, so 10,000 was the right number from a few years back. The new bingo number is 11,340. They have the right to fine you that much for each student that's not wearing goggles, but I've never seen them do that. They've only involved the one fine because students have goggles up on their foreheads or down on their chins, like they used to do with masks when we had COVID going on.
Oh, yeah.
So 11,340 is their new magic number. They probably made it that. That's an actuarial decision that was made. That's probably to account for inflation. But they really don't want your money, believe it or not. So they will usually give you a time frame in which to show forward progress. You don't even have to have the problem solved. You just have to show that you have ordered or that you've sent in the requisition and that you're waiting for a PO to order these. As long as you can show forward momentum to solving the problem, you probably have about 30 days to do that and you won't have to pay the fine. So they're really not after making money. They're after keeping places safer. Now, I use the word safer deliberately. How many hands would go up in the room if I say, can you make your science lab safe? If you agree you can, you would put your hand up. How many hands are going up?
Yes, everyone believes that that can happen.
Okay, so I have a question for you. Are there natural gas lines going through the walls of a science lab?
Yes.
By definition, that puts you in a hazardous space that you cannot make 100% safe. Until there's no gas in the walls, it's not going to be as safe as a regular classroom.
I may have wrongly said that. I only had like 4 hands up.
Okay.
They believe you.
Okay. So since we can't make it 100% safe, we have to make it as safe as possible. So everything that we do is making it a safer space to learn. And that's our drive. And that's what all of this PPE and rules and regulations are about, is making it safer for staff and students to be in that space. Hand protection. In the past, and I'm old enough to remember when latex gloves came in, but latex gloves now are a problem. Anybody know why?
Allergies.
Yeah. And not just a couple. There are a ton of them out there. So honestly, don't even waste your money on latex gloves just because you have a few people that might be able to wear them. Everybody can wear nitrile gloves. Just keep boxes of multiple sizes around. But if they're anything like my colleagues, be aware that they will disappear quickly. They will have people from the cooking lab coming down to get them. Oh, I just need to get some gloves. We don't have the right size in the cooking lab. Okay, but then who replaces them? Yeah, that ends up in our budget. So at the beginning of each year, take account before school starts of any PPE that needs to be replaced and get on that order like yesterday. We need to have it all in place before we start labs. Now, also, don't try and save money by reusing nitrile gloves. Bad idea. Super bad idea. They're single-use products. Aprons or lab coats. There's some debate out there which is more like, is a lab apron appropriate? And for a lot of situations it is. But if you're going to have acids, bases, corrosive stuff, sleeves aren't a bad idea. They may save somebody from having a burn or their clothing from being eaten away. So if your department can foot the bill for lab coats, great. But a lot of places just use aprons and tell people to have long sleeves on the day of the lab, just in case there is going to be a splash. Now, do you know how to deal with a lab coat that's dirty? Or do you want to wear a lab coat that the center from the football team was wearing last lab?
We're getting a lot of no's.
Yeah, no, let me tell you, if you're a center, you sweat a lot. You're a big boy. So you don't want their lab coat the next day. If you want to clean them, it's real easy. Wash them. Just don't wash them with anything else. Do not put your tidy whities and your socks in with them. Not cool. Not a good idea. But you can wash multiple lab coats together and you can use regular detergent on them. If they've had any acid or base splashed on them, though, they will probably have little holes in them afterwards. You've all seen that on coveralls coming out of mechanic shops that they worked with battery acid. Same thing. Same thing. But you can wash them in your washing machine most times. If you have aprons, those don't go in the washing machine. Those you just use a sponge or a cloth of soapy water and then a damp cloth to wipe them down and hang them to dry. Sounds like a lot of work, but I would rather have them clean rather than making people dirty just by putting them on. Chemical storage. Again, if you do a survey, a lot of people think that if you have chemicals in bottles like you see in the picture there, should you be storing them alphabetically?
We have a lot of no's, but I gotta
Yeah,
tell
I'm glad. You should give all these people a raise. Just saying.
Phil, I inherited a chemical cabinet that was by alphabetical, and I was like,
Yeah, that used to sound like the smart way to do it. But you can only do them alphabetically if they're within their own storage grouping. So for example, your acids should not be on a shelf. They should be in an acid cabinet. And within the acid cabinet, you can put them alphabetically because they're all acids. However, this is where life with an SDS comes in. Does everybody know what an SDS is? Yeah,
I'm getting
so-
some people that might, you might want to mention it.
So it stands for safety data sheet. We used to call them material safety data sheets, but we changed their format when we changed out of WEMIS and we went to GHS, global system. So we can look on the SDS and it will tell us what storage categories that these chemicals belong to, but they will also tell us whether or not there is a chance that they will react with something that they're stored beside. So not all acids are created equal. One acid that I hope that everybody can find a way to get rid of from their lab is nitric acid. It is very reactive. It needs to be stored on its own in its own container inside the acid cabinet if you have it, but I'd recommend not having it. A lot of people will hang on to it for doing titrations. There are other monoprotic acids that you can use to do a titration that work equally as well as nitric acid. Nitric acid is just too reactive to really hang around. It should be disposed of, just like methanol. Get rid of it. Your bases do not go in the cabinets with the acids. They go in a base cabinet. Your flammables, you can store those in a flammable cabinet alphabetically, but they all have color codes on their labels and wording on their labels because the labels have all been unified. So no matter who you buy it from, the label should be the same now. That's why we went to an SDS. The MSDSs used to be company specific. So you would get slightly different information on them. We have harmonized them across the globe. They are now identical no matter who you buy them from. So they will give you the same identical information in the same identical sequence, the same 16 sections on the SDS. And if you don't have an SDS, like they come with every chemical you buy, but if you don't have one, you can go to places like Flynn, Boreal, VWR. You can go to their websites and you can download your needed SDS for free. Just print it right out. So, chemical storage standard operating procedures. Once you're done using a chemical, put it back. And your chemical should be inside a chemical storage room that you keep locked, and a sign goes on the door saying no students permitted beyond this point. That is protocol. That needs to be something that's in place. If you notice while you're prepping for a lab that you have a broken cap or a missing label, you can usually print the labels out. They usually have the standard Avery formats for label sizes that you can print from. But any broken caps, you can usually give the company that you bought it from or any company a call, because I think the cost to the company is about 7 cents per cap. So I'm pretty sure they can give you a few. So they would just pop them on a courier and send them over to you. Because if you have cracked caps, then one of the problems you have is off-gassing, where chemicals start to evaporate, and then they can interact with other chemicals in there that are doing the same thing, and we can have a problem. So I want to show you a picture. Do you see the door? The inside of that door? Everybody can see that? Okay, I'm going to jump ahead a couple slides, okay? Can you see that light blue acid cabinet on the top? Yeah. Okay, the inside of that is this door. What happened inside this door is there were two chemicals that reacted with each other and they started corroding everything from the inside out. I don't know if you can see from where you're sitting, but even the walls inside the thing, front and side and back, are rusted out. So that cabinet is almost at the point of no return. You're going to have to replace it. So knowing interactions is important, and they're on the SDSs. And you should have a binder of all the SDSs of all the chemicals that you have on site available for anybody to grab and use in the chem lab. Some people have, these ones have locks on the doors. Some do, some don't. Most will nowadays. And some people are trying to say that only the science teacher should have keys to those doors. That's a little bit argumentative. I can see why, because you don't want anybody else going in there. But sometimes you may need to leave a key with admin in case an emergency happens and they need to be able to open it. Otherwise, no, don't share those keys around or don't leave them for a sub. I'm not a big fan of trying to get subs to do your labs. Okay. If you look at this picture, I don't know if you see the middle label. Can you read it from where you're sitting? Yeah. No, not good at all. My biggest problem is sulfuric question mark. Well, maybe it's sulfuric. Huh? We think it is. And it definitely looks like sulfuric, not hydrochloric. I can tell you that right now. Like, oh my gosh, no, I can't. That, I don't know. I do not like question marks on tape labels on bottles. I just, and the white powder that's around there is because they got a reaction in the cupboard, in the acid cabinet, and somebody tossed some baking soda in to try and neutralize it, which isn't a bad idea. The fact that you got a reaction in the lab, in the acid cabinet, that's the bad idea. And you'll see the brown bottle on the right. Not only can you not tell what's in there, there is absolutely no way of knowing. So do not just throw bottles in because it's a convenient place to go. If you do not know what's in them, do not assume. I would dispose rather than assume. That's a dangerous thing to be doing. And it is illegal for you to actually have bottles labeled like they did with that sulfuric, maybe unknown concentration. Yeah, you have to have a proper GHS label on there with all the proper information. Like I say, you can just print them out from websites and put them on the bottle if you have labels to print onto. If you can smell your chemicals in your cabinet, chances are good that something in there is letting those smells off. Now, I studied for 8 years to get to that conclusion. Like, it's a good telltale sign if you can smell stuff in there. And I don't just mean like it smells like a chemistry cabinet. No. I mean, you're smelling a specific chemical in there fairly strongly. Yeah, something's leaking. Something's off gassing. Don't be inhaling too much and back away until you can put on a proper respirator and figure out what it is. All right. Chemical inventories are something that takes a little time up front, but once you have the system running, and there are plenty of systems available, I don't recommend one over the other. Just I recommend that you do have one so that if there's ever a fire or an accident in the lab, we know what's present in there, and the fire marshal will know what types of equipment they need to have based on what could be burning in that lab. All right. By the way, how many people shop for something based on price per pound or price per ounce?
Yes, some people do.
Yeah. If you're my age, we grew up through the era that was a good idea. Nowadays, not so much. Have you ever looked at the expiry dates on chemicals? Most run around the 3-year mark. So if it's a better deal to buy 10 pounds of something because it's cheaper per pound, do you think in 3 years we're going to be done with it? And the answer is no. You really won't, because you're not doing that many labs with the same chemical. So unfortunately, it's more per ounce, but it's definitely, you're going to be disposing of less, and it's far more expensive to dispose of it than it is to order more small bottles of the same chemical. Has anyone had to see the bill for having the disposal company come around and round up chemicals? It is
Doesn't look
not.
as though, yeah, no.
Okay, so it is not uncommon for that to run at $10,000 a school. So that involves transport, the personnel picking them up, transporting them, and then dealing with them when they get back to the facility. So it's not cheap. I would rather spend $2 more on a bottle that's smaller and knowing that I can use it up before it's expired, and then I'll just order another one in 3 years. So it's cost me $4 in 6 years more than it would have per that size of product if I bought a big bottle that I'll never use up. So the days of buying in bulk to save money, not so cool for a chem lab. Just consider ordering what you think you can use, and not what you can save some money on. I have a little strategy that I want to throw at you. And maybe I'll save it for when we get, you know what, I'm going to save it. But when I get to the part about asking you about how many chemicals you should have, somebody needs to say the word dots to me. Just DOTS, dots. Is there a volunteer that'll just yell that at me when we get to that question?
Yes, we have some that will do that.
Good, excellent, thank you. All right. Oh, it's on here. Look, it's in here in the writing. I didn't even read it. Colored dots. If you go to dollar store, now you don't have to yell at me. If you go to dollar store, you can get those little sheets of colored dots. You know which ones I'm talking about?
Yes.
Yeah.
Okay, good. You get like 1,000 in a package for $1.50, whatever they are. 1,000's great. You're not going to need more than that. But here's, you go to your faculty, and if somebody wants their own sheet of dots, give it to them. If it makes them feel important, wonderful. So you take a sheet of dots, and here's what you're going to do. You're going to ask everybody that's going to be using chemicals to take a colored dot every time they use it and put it on the bottle. It doesn't matter what the colors are. There's no sequence to color coding here. And if they use it 3 times, they put 3 dots on it. It doesn't matter if they're the same color or not. You just want a dot. This is simply a counting exercise. So what you want to do at the end of the year is look at your cabinet and look for the dots. Are there any bottles that don't have any dots at all? If they are, ask yourself, do we need these chemicals? And maybe if you're running a course only every second year, this might have to be done every second year then. But the dots will tell you how frequently a chemical is used. And that will also indicate the quantity that you need to be ordering it in. But you and your department should be able to sit back at one of your meetings and say, all right, so here's the chemicals, here's our list. So I'm going to ask you the question now. How many chemicals do you think it takes to run a 4-year science program in a high school? What is the recommended number of chemicals to have on hand for all 4 years? Or all the courses of all 4 years?
Anybody got ideas? Shout them out.
12.
10, 12. That's what I'm hearing.
Okay. So the recommended number so that you have enough chemicals for every course that runs from 9 to 12 in 1 year is 70 to 75 max. Now remember, here's another thing to remember. The minute that you bring baking soda, so you go to the store, you buy the Arm & Hammer, the Cal brand, whichever one you get. The minute you bring it into the science lab, it's no longer a commercial product, it's a science product. So it should be labeled properly, and it's now subject to being a chemical in your chem lab, and it has to be in your inventory. So that list of 70 to 75 includes your vinegar, your baking soda, your activated charcoal, all of that stuff. Those are included in that list. So you can see how that takes up a number of blanks on that list. But 70 to 75 is the max. But you yourself, if you think about how many would you use in your freshman science course or your 11th grade chemistry course, whichever, I'm hard pressed to find a course that will use more than 20 in a year. Would you agree?
Yeah.
Okay. But we would want to make sure that we have those 20 on hand then. And that's what these dots are for, is to track down what people are using. Because I may not be the guy that's teaching chemistry. I may be the department head, but I need to know what they need because I want to have it here for them. So we use this dot system. They just come in, I'm going to use it today. So the first thing I'm going to do is I'm going to put a dot on it before I use it so I don't forget. And then I go ahead and go about my business. And at the end of the year, if you find a dot with 20 or a jar with 20 dots on it, you know that that's one that you should keep on ready order because it's going to be used up fairly quickly because everybody's using it. So something like sodium chloride, lots of people use that. Or your ethanol or your phenolphthalein or whatever it is that gets used commonly. You'll see a bunch of dots on it and that tells you, okay, if I've got less than a quarter of a bottle at the end of the year, I need to order one for next year because it's going to be gone. So just a cheap and easy way and a quick study of what do we actually use. So let's see what we need to keep on our order list for each school year. I hope that makes sense. All right. Has everybody seen this chart of 9 symbols? There's actually a 10th one at the bottom, but it's not one that we see commonly in high school. Everyone seen these? They were the old Wemyss symbols.
Yeah.
They've been moved on
And
to.
a lot of heads are nodding.
Yeah. Having these on a poster somewhere in the room would be a great idea. Just so everybody's aware of what those symbols mean. They're pretty straightforward, most of them. If you see a picture of something blowing up, that probably means it's explosive. Or if you see a flame, that probably means it's a flammable. So a lot of these are straightforward. They also have to be on the labels by law of each chemical. Any hazard symbol has to be on there. And any label that you can print out will have them on there because they can't provide them for public use if they aren't complete. Okay, so we asked this question already. We said 70, 75 max, but you can probably do it with significantly less. Waste management. Now, by the way, can you see what that little bottle has in it from your seat?
Masking tape seems to be the general consensus. Quite
Okay,
old.
look
masking
lower. Look lower.
tape. Look close. Oh, mercury.
Do not have any of that in your school. That is a nasty, 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 nasty substance. It should have been gone years ago. We found this little wee bottle of mercury. It's about a pound of mercury at a school. The disposal fee for that is about $3,000 for that little bottle, I think, is at the time. So it's not cheap. But if you have any mercury thermometers, old barometers with mercury in them, any manometers, all that mercury stuff's got to be gone. It's just a very targeted carcinogen. It needs to go. And let me tell you from personal experience, anything that has carcinogens, you need to get rid of them, like right now. A lot of people think, oh, it's not going to hurt me. So I'm from the era in the early 80s when I went through my undergraduate science. I was doing a zoology degree and I was going in weekly to do dissections in the zoo lab. And I'd reach into buckets up to my elbows or higher in formaldehyde. And then in my organic chem lab in second year, I was asked to take benzene and make myself some toluene. That was the lab instructions. All 3 of those things are carcinogens. I went through all that. We were using carbon tetrachloride as the zeroing solvent for dissolving everything in to do NMR work in the biochem lab. So the nuclear magnetic resonance analysis, which will show you what chemicals you have in your unknown sample. All of those carcinogens, I thought I got away free and clear, because I wasn't harmed by any of it, and I splashed around in it for years until we knew better. And then last year, I ended up going through 6 months of chemo for non-Hodgkin's lymphoma. It caught up. When they say they're carcinogens, they aren't lying. They absolutely aren't lying. So take it seriously. If you see preserved specimens in a bottle that looks tannish in color or beige, don't even open it. Don't even have it near your desk because it is famous for going around the threads of caps and off gassing where it sits. And then you're breathing in formaldehyde fumes, which was the big problem when we started with that urea formaldehyde insulation. People put it in their walls because it was a fantastic and easy to install stuff. You just drill a hole and pump it in from a truck. It was beautiful. And then all of a sudden, people started getting very, very, very sick all over the place. And we found out that that UFI was off gassing formaldehyde fumes right into the home. And people were getting cancer all over the place. So we had to go around and remove it all. It was terrible stuff. Terrible, terrible stuff. So if you have any formaldehyde in the lab, isolate it. Do not have it anywhere near where anybody's sitting. And dispose of it ASAP. Mercury, do not wait to the end of the year to dispose of it. That needs to be dealt with right now. I'm not sure why formaldehyde doesn't get the same treatment, but they should. But formaldehyde, you can leave to the end of the year and combine it with everything else that needs to be disposed of. Mercury, no, you need to get rid of it. All right. Your district should have, if it doesn't, and will have in the near future, if it doesn't, a chemical hygiene plan that has in it all the disposal features for working in the chem lab. Also, the SDS has proper disposal instructions on it for every single chemical. So if you don't know, don't assume that the drain is the right place for this stuff. Also, using a 5-gallon pail that you're going to pour every ounce of waste into because it's all in one place, not a good idea. You have no idea what's going to react in that bucket. The last thing you want to do is pour it in there and have something explode. So learn what you're supposed to do to dispose of various items when you're using them in the lab. And this is where one recommendation, if I could make it super strong, would be if you're going to prepare for a lab, give yourself about 3 nights ahead of time so that you can inspect all your equipment, make sure there's no frayed cords, make sure that all of the emergency equipment works, make sure you know what to do if something goes wrong, and make sure you know how to dispose of stuff at the end of the lab properly. When you have all that in place, you're ready to go for the lab if you've run it through yourself at least once. So it's just safety at its finest. I can't recommend it enough. And if you don't know, ask. Please don't be too shy to ask. Do not take asking a question as a sign of weakness. It most definitely is not. It is being smart. Okay, well, let's see. Where's my mouse going? Here we go. Whoop. Chemical spills. Do you have spill kits in your lab?
I have mostly no's.
Okay, all right. So chemical spills with acids and bases, you treat them with the opposite. So really, in my lab, I have I don't know, it's about a 2-gallon container, and I filled it with baking soda. If I have an acid spill, I'm going to put the baking soda on the acid to neutralize it so it can be cleaned up. I also have a similar container that I filled with citric acid. It's a powder. And if I have a base spill, then it's just going to be poured on that. I also have a container of Zorbol, or you can use kitty litter if it's a solvent spill. You can't use the acid or base kit on a solvent spill. You need to contain it, and so you can put the Zorbol or the kitty litter around it and then over it to keep it from spreading. When you have a spill, don't try and pour water on it to clean it up. Do you know what that actually does?
Spreads it.
Yeah, makes a bigger spill. That's all it does. It may dilute the acid slightly, but it's just going to spread it out over the floor or the counter or wherever it is. So you need to contain it with sand or Zorbol, kitty litter, keep it contained, and then put the appropriate spill kit on it. And they're easy to keep. They're just containers with easy, cheap stuff inside it. So having spill kits in the lab, super, 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 super recommended. And if you ever have a spill, please tell the kids and yourself, don't panic. The minute people get into a hurry and oh my gosh, and then we have problems. Things happen in the lab. It's a fact of life. So we've done our safety training. We know what to do. Stay calm, deal with it. And things go very well when you do. By the way, in the picture, excuse me, in the picture, can you see a black dustpan and brush?
Yeah.
Okay, do you know what that's for? That's for your broken glass.
Yep, they got it
So-
right.
Now, where do you put that broken glass once you swept it up?
Principal's trash can.
We got the principal's trash can, Bill.
Ah, yeah, there we go. Let's give him fibrosis of his lungs. Okay, so there used to be in my lab before I learned better, a 5-gallon pail that I would keep glass in because the glass can't puncture the container. And if the glass happens to have any substance on it, it could leak out through the hole. So I thought a 5-gallon pail was great. The problem with the 5-gallon pail is when you open the lid. When glass breaks, the really, really tiny parts are like fiberglass. They're glass fibers, and you can inhale those, and they're really not good for you. So there are proper glass, broken glass boxes that you can buy, and they usually come in boxes of 6 for like $100, $130, something like that. From Fisher, from Flynn, they're lined with replaceable bags that are puncture proof. But you also have a flap in the lid that you just push the glass through so that the fibers can't come back up through you and you inhale them. So if you haven't got the broken glass box in the lab, ask for it because that's the proper way to handle the broken glass. Is sweep it up, reserve that dustpan just for glass, but then make sure that you dump all of it into the glass bin, the glass box. Okay. A flammable spill. On section 6 that you'll find on the SDS sheets, they have this nice politically friendly phrase, accidental release measures. That means, crap, there's a spill. So what do? First thing, never, ever, ever mix water with it. I've told you that already. But if this is a flammable liquid, let's say ethanol, and somebody walked by the counter, hit it with their elbow, where does it go from there? All over the floor, right? Hopefully not onto anybody, but onto the floor. And if there happens to be a Bunsen burner nearby, we have a little bit of a problem. Or an outlet, and it happens to splash into an outlet, we have flame risks. So we need an absorbent material. And then once we have it fire out or soaked up and no fire has occurred, then we can sweep it up and seal it in a vinyl pouch or a bag to dispose of, according to your chemical hygiene plan, your district's plan. An acid spill, like I told you before, you're going to put a base on it. So sodium carbonate, sodium bicarbonate, you want to just neutralize it. No, you don't have to do any calculations to make sure that you use exactly the right number of grams to neutralize that many acid. That's reserved for titrations. Just dump it on there. Dump it on there. More is good. And then clean it up according to your chemical hygiene plan. Base spill, same thing. And again, all this information will be on the SDS that comes with that liquid. There's what a glass box will look like. Most of them look almost identical to this. They're just, it looks like a cardboard box, but you can see that in the top, there is a place to push the glass through so that you won't get any fibers in your lungs. Please do not try. I know a lot of us grew up when a bottle of jam broke on the floor. You would pick up the bigger pieces with your hands. Don't do that in the lab. Please do not do that in the lab. Do not touch the glass. You do not want to cut yourself and then have whatever's on that glass injected into your bloodstream. Please don't touch the glass. Put it in the broken glass container. And when that thing gets full, you can pull out the liner. You can buy new liners to put in there. I think a bag of them is a couple hundred, 100 of them. There is $150 or $200. I forget what it is. They last forever. They don't expire. So easy thing to have on hand for broken glass. So having come this far, a quote by Baldwin seems appropriate. Recognizing a problem doesn't always bring us a solution, but until we recognize the problem, there can't be a solution. So like I said before, please do not hesitate to ask somebody if you are uncertain about something. Not asking a question can often be more harmful than asking a question. So please don't be afraid of saying, I'm not so sure about this. And if your spidey sense tingles about a lab, don't do it. Just don't. And if you think you are using something particularly hazardous, you can phone us or Flynn or any of the other companies out there and ask, is there a greener solution? In other words, is there something that's not quite so harsh that I can use to accomplish the same outcomes from the lab? You're going to hear me talking later about a risk analysis on a lab. If you think that the risk outweighs the educational outcome, just don't do it. Just don't do it. Find something else to do. Also, here's a question for you. I'm curious. If you're in the middle of a lab and your principal comes to the door, are you going to let him in the room or her in the room?
Goggles and PPE.
Yeah, goggles and PPE.
Okay, that person there raised their salary 25% right now. Right now.
She's
They need a
very
raise.
excited
That is
about it.
exactly it. When you are doing a lab, your principal now becomes a student as soon as they want to set foot in the lab. They must be equipped with the same PPE that you and the students are equipped with, or else they're not coming in the room. And you got to have the kahunas to stand there and say, you're not coming in. It is against OSHA for him to walk in unprotected.
Or her. Or that.
Or her. I'm sorry. I'm old. So pardon me. So the same goes for any visitor that comes in, a superintendent, a director, whatever. They cannot come into an operating lab without proper PPE. And nor should you abandon the students to talk to them in the hallway. How many of you can predict what would happen if you left a group of grade 9s doing a lab unsupervised? Oh boy, that's a bad day in Little China right now. I'm telling you. Oh, how long does it take for somebody to do something not instructed the minute you're not in the room? I'm going to say it falls in the nanosecond range. So please, 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 please make sure that everybody is following proper safety protocol, including any dignitary that may come to the door. That's just the way it has to be. All right. Everybody shares a duty in safety. It's inherent in being a teacher. We have the safety of children as our priority. So it behooves us to make sure that we are up to date on proper safety procedures. And that's where I've mentioned before that your school district should be tracking when you have had your annual safety training, because everybody should get it once a year. And it doesn't have to be the full training course. It can be an update, but you should make sure that everybody has it. But nowadays, the statistics are showing that teachers are turning over relatively fast in their teaching career. Over half of the teaching profession will leave teaching within the first years of entering the profession, first 3 years. So if that's the case, we're going to have a lot of people new to the department annually. So we got to make sure everybody is trained at all times. We should not have somebody who's not familiar with safety protocols operating in a science lab. And like I say, we should be hopefully pairing them up with the experienced people so that everybody can stay on the straight and narrow. All right, identifying hazards and risks. You've all seen these 4 basic symbols that we picked to put on this slide. But I'm going to say if you see the one on the far left or the far right, run. I don't want to be in a room where there's a biohazard symbol in there. That's just not for me. And radioactive, no, don't want to be in there unless it's, a physics lab at a university where all the proper protocols are in place. But hopefully we never see either of those symbols in middle years or a high school facility. We shouldn't. However, we will see plenty with the red diamonds because those are the 9 symbols that we saw earlier. And physical hazards should be well labeled in the school so that we don't have anybody having an accident because they didn't know that there was a risk present. So signage important. We are moving forward nowadays with experimentation with the advent of STEM coming in and maker spaces, fabrication labs, CTE spaces. These are becoming increasingly popular and it's a wonderful thing to be doing. But because we are doing a lot of work with a lot of equipment, safety standards become paramount. We need to make sure that every student in these spaces is aware of the needed safety protocols. And you said that earlier. I heard a lot of people in the audience say that the best way of avoiding accidents is safety training. And it's 100% true. 100% true. Demonstrations. So in the picture, is there something wrong with this picture?
We have them wondering if it's just one thing.
No, you're right. It's not just one thing. However, the first thing I noticed was who's supposed to be seeing the demonstration? The students. Here we have somebody amusing themselves. Hopefully that's not a student, but nobody else can see it. It should be around facing the other way. But are you a fan of running a drill 12 inches from your nose? Not cool. I just don't like that idea. And this is probably the color wheel to demonstrate that they'll blend into white when you spin them. Way better ways of doing it than a power drill. And having loose hair and no goggles around power tools, just no go. No go. So you're right. There's multiple things here that are a problem. What's another way we could accomplish the same thing but not use the power drill? Yeah, okay. So if we took a pencil and put it through where the bit goes through, and then we just rolled that pencil between our palms, we can get that thing to spin fast enough that it'll turn the colors to white. Is there any major risk to spinning a pencil between your palms?
If there was, somebody would stop the kids doing it.
Yeah, it takes a major doing to make that risky. But it's certainly a whole lot better than a power drill that they're going to stare at. That is just not a good idea at all. At all. Likewise, again, do not do a demo if it poses a risk. Just don't. Find a safer way to do it. And if you don't know of one, Google it, ask somebody, phone a company and say, is there a better way to do this demonstration? Reduce or mitigate the problems. And of course, you should be using her proper goggles. For that, at least those ones with the side shields on them. This is another bad idea. If you look from where you're sitting, it probably looks like there's masking tape running up the side of that thing, yes? So it's not masking tape at all. That's actually a rolled up map or something. Those are pictures. But my problem here is, what if she gets a hiccup? I don't know what's inside there, but what if she gets a hiccup? Yeah, we got a problem. And you spoke earlier of modeling safe procedures. Is this modeling a safe procedure?
No.
No. So if you're doing a demonstration purely for entertainment value, maybe rethink whether or not you need to do that demonstration. If it's purely for entertainment, and I know that we like to try and do the whiz bang stuff, those days are over. Unless you can tie it to an educational outcome, just don't do it. If all we're doing is entertainment value, students will learn nothing. So, again, we're limiting what we can do to what's safe and what's educational with the students. And then things become much more valuable, and extremely safe. So, do you know what to look for if you're doing a hazard assessment or a risk assessment? This is what I talked about earlier. Dr. Ken Roy basically said that you need to look at the educational value versus the potential safety hazard. And if the potential safety hazard has a larger impact than the educational value, do not do that activity. Just don't. And again, look for different ways of doing different things. Formaldehyde was the world's greatest preservative. It worked wonderful, but it's a very potent carcinogen. So we've replaced it everywhere. We now use a glycerin-based substance that does not off gas, and it is not harmful, toxic, or carcinogenic. So there are other ways of making things happen. If you are not convinced that you are doing things safely, don't do them. So how do we look for this? This is a particular method that Dr. Ken Roy invented. He called it the AAA method. It's now in the NFPA document. So we take, how does this AAA work? Basically, it's three things. You do a hazard analysis. In other words, look at the SDS and in tandem with your experience and any notes that you have from the lab activity itself, look at your chemical hygiene plan and see if you're contradicting any chemical safety measures. If you are, don't do it. Okay, if the hazard is minimal, it's potential but not guaranteed, then you have to weigh it against the educational outcome that activity is supposed to generate. You do a risk assessment using those particular sections 2, 5, 6, 10, 11 from the SDS that tell you all about the safety, all about disposal, all about all of those things, what to do if it spills, what to do if there's a fire. All of that's on there on the SDS. So do your risk assessment by studying the SDS and learning the actual risk to the substance that you're using. And finally, your action. What happens if there's a problem? What are you going to do? And this all should be done prior to doing a lab. So can you handle it if this stuff spills? Or can you handle it if there's a fire with this stuff? Do you know what to do? Do you know where the safety equipment is to do that? And have you checked them to make sure that that fire extinguisher is in fact at 100% or not? So all of that. Do you know where the shutoff is for the gas, the control valve, if we need to shut it off and shut off the Bunsen burners? So these are all things that we can do prior to doing the lab to maximize the safety potential of that lab. In our company, we like to divide chemical hazards into 4 groups: chemical, biological, physical, and electrical. We added electrical because nowadays most of your equipment is going to plug in. So those have their own sets of risks associated with them. When you're using microscopes in a biology lab or in a freshman lab, do you ever check the cords?
We're getting mostly yeses.
Great. Excellent. Excellent. These people should have like double the salary by the time the day's over. These guys are great. So with those microscopes, quite often people will wrap the cords around the lights at the bottom. And one of the things that does is puts a torque on the section that's right adjacent to the base of the microscope and crack crack the rubber housing on the cord. If you see that, that should be taped up with electrical tape, not left exposed. And if possible, have it replaced with a new cord. So inspecting all of those cords, and I recommend not wrapping up your lights that way also, because if the light happens to be hot and you wrap a cord around it, then it might melt the housing of the plug. I recommend bunching them up into little figure eights and putting an elastic band around it, or one of those zip tie things that come on the cords quite regularly. So these hazards exist. By the way, anybody have living creatures in their classroom?
Got a few.
Okay, cool. And those
Other
are,
than the students, right?
yes, yeah,
Okay.
true. Those are great things to have in the classroom, but before you bring one in, of course, knowing if somebody's allergic is a good thing, but also knowing what's going to be done for those creatures during holiday sessions. Who's taking care of them? If you have a 2-week mid-year break, Christmas time, who's coming in to feed them? You can't just abandon them. So these are plans that have to be in place. Even plants, you got to water them. So knowing who's taking care of them and having those plans in place ahead of time, especially summer, critically important before you decide to bring a living animal into the classroom. Critically important. And how are you getting the food to feed them? And who's feeding them? And when are you feeding them? And are they safe to be handled or not? All these things have to be investigated prior to bringing them in. Physical hazards are what we examine the lab for at the start of the year. Have we cleared out the clutter? Have we got rid of anything that could fall on somebody's head? Quite a few places are now outlawing storing stuff on top of the cupboards if there's a space between the top of the cupboards and the ceiling. You're not allowed to put stuff up there anymore in a number of places. Have you inspected your equipment to make sure there's no leaks in any hoses, any rubber hoses going to Bunsen burners, that kind of thing? Do you have the location and or the key for the shut off for the gas, and or do you know where the emergency shut off for your electricity is? So all of these things need to be taken into account as we start a school year. So here's some stuff that should not be in your lab, if at all possible. Aerosol canisters. I know it's impossible to not have any aerosol, but it's getting close. It's getting very close to being able to do it without it. Acetone-based solutions, it's because it evaporates so quickly. It's so flammable. Alcohol fuel burners. Do you have any of those left in your labs? Those little glass jars that had the metal cap with the flat wick that came up through it? Do you remember those?
Yes.
If you have any of those left, get rid of them. They are a humongous risk. You don't want any of those around. Because one of the problems with those, especially say at the grade 9 level, and a kid comes racing through the lab chasing somebody else because that's their favorite thing to do, and they happen to swat one of those, what happens? You now have a flaming projectile heading at somebody somewhere that when it hits them is going to spill on them and is going to burst into flames. These burners are just lawsuits waiting to happen. So if you have any of them left, get rid of them. Just get rid of them. Do not use them. Do not. How many of you are still doing the lab, going to the water fountain and swabbing the water fountains and culturing them on a dish to see if we get cultures? And what's the supposed dirtiest surface in the school? Do we do that lab anymore? Well, if we do, we probably shouldn't, because the problem is, yes, you'll get cultures, but do you know what they are? And if you open that lid to look at them, do you know what they are? And do you know if spores have just decided to enter your system? Yeah, not such a cool thing. I would recommend not doing the culture swabs anymore, simply because we pick up stuff that we don't know anything about. and then you put them in optimum growing conditions, a little incubator, and think we're doing a good thing. No, we're really not. And then do you know how to get rid of them? What do you do when you're finished with them? So it turns out that the proper way to dispose of one of those petri dishes is soak it in bleach for 15 minutes first. Then you can dispose of it in the garbage. But it has to be pure bleach, not watered down bleach. All right. You'll see that body fluids are out because of bloodborne diseases, different things like that. We need to make sure that we don't have any known allergens. If we have somebody that's allergic to peanuts in the room, we certainly don't want to keep a jar of peanuts in the room. Now, concentrated acids or bases, and I'm going to end the list here pretty quickly. Concentrated acids or bases, how many people purchase their acid as the 16 or 18 molar stuff that you can get to take aliquots out of and dilute and make the proper concentrations for your lab? Do you buy those super concentrates or not?
I get no to occasionally.
Okay. We used to do it all the time in the old days because that one bottle would last a long time. But it is super, super risky, especially if somebody brings it out of the prep room and puts it on the counter and that's their workspace. If that gets knocked over, that potent stuff is just going to corrode anything it touches badly. Badly. So it's not worth buying the 16 molar stuff. You really, really shouldn't need anything in the lab that's more than probably 1 molar. I'm gonna put myself out there and say 1 molar is probably the limit of what we need for a concentration. I don't remember many labs, if any, asking for more than 1 molar. Am I wrong? Is there anybody out there that can tell me I'm wrong?
Nobody seems to think, nobody's disagreeing with you.
Okay, so I think 1 molar is our limit, so let's not go for those big super concentrates. Further down, you'll see formaldehyde on there. Gotta go, gotta go. And if you see anything in a jar that's a baby food jar or a cooking oil or something that came from home,
Yeah.
one of those precious gifts that you get from somebody. Here's a chick that didn't make it. I thought you could use it in the lab. Okay. Do not hang on to it. Please do not. Please dispose of it properly. Find out how you're supposed to deal with that. Maybe give the vet a call and say, here's what was brought in. What can I do with it? Please don't.
Yeah, I'm gonna interrupt a second, Phil, because what happens with high school teachers is some of them are coaches, some have parent-teacher conferences, etc. So we're running low on time.
Oh, I'm terribly sorry. Okay.
No, that's totally not on you. That's really on us because we ran into that little technology issue at the beginning, and I see you've got some of those more those excessive risks listed up there too, and I think that's really good to take note of those as well.
And we pretty well hit all of those, 90%
Yeah,
of these during that.
so, can I ask just a quick, can we go over disposal really quickly? I know that's not a quick question and maybe we can, but like, there's a lot of band items you've got up there too. I'm certain that we'll have the slide deck we can send out of some version of that too, if needed, so we can reference it. But is there, like proper disposal of some of these items we will find in our chemical cabinets that we need to, of old preserved specimens, Stephanie said in the chat, or of things in our chemical cabinets that we need to get rid of? Is our local county something going to help us with that, or is that something we need to bring a company in for?
Usually when it comes to chemicals, especially, you will have to bring in a company to get rid of it.
Okay.
The majority of them, they will tell you to isolate them, put them in a safe storage place, do not let them react with anything else. And at a specific date, they will come and get everything that you've got all at the same time.
Okay.
The only one that I've heard of so far that they will get rid of instantly and you can't hang on to is mercury.
Okay.
Otherwise, they will usually tell you isolate it, put all your formaldehyde in one place, seal it off, make sure it's not going to off gas anywhere near people, and call them and ask for a date that they're going to come so that you have everything ready to go at the same time.
Okay,
But
that's,
but
And what
there as
about-
well, giving a call to the company that you bought it from, if they're still around, would be a great idea as well.
okay. And then, those biological preserved items.
So preserved specimens, those quite often, it depends on what they're preserved in, because if they're preserved in formaldehyde, then you have to have the company come and take them away. But if they've been preserved in the glycerin based, those ones typically, if you wrap them up, and I still think they're going to have to be disposed of with a company coming in, because you can't just throw a preserved specimen in the garbage.
Okay.
So again, check with your district to find out what the rules are on that.
Okay.
Or phone VWR or somebody and say, what do you recommend with these specimens once we're finished with them?
Okay, perfect. Audience, before I have to cut Phil off just due to our time so we can get you guys out in a timely fashion, is there any other quick questions that you have for him? I mean, it's quite thorough, basic, probably things that it's just good to be reminded of, I think, and then some of those nice little technicalities to have in our back pocket. Because this is the group of people that are going to be advocating in their districts for cleanup, I'm sure. So that's super helpful. All right, Phil, thank you so much for your time. I will communicate more with James as we move forward, but this has been super helpful, so thank you so much.
Not a problem. One last thing I might recommend to people if they're looking for safety information, NSTA has a series of publications available for people to look at on their own. If they're an NSTA member, they can purchase it at a discount, or the school wants to purchase it for them. Lots of great material out there.
Yeah, perfect, thank you. Well, I appreciate your time and energy, and we will, yeah, we'll look forward to March 2. So thank you so much. It was nice meeting you, Phil.
Thank you for
Everybody,
having me.
all right, okay, we'll be in touch. Thanks so much. Okay, oh, good. There we go. Yes.